All right, so 1.5 was your composite functions. We learned how to add, subtract, multiply, divide, and then do the combined functions where it's f of g or g of f. So, and we did it with equations and with graphs, so make sure you know how to do both. We'll touch on it again a little bit later, but this was just the equations. So f plus g would mean literally take the f and add it to the g. So 3x minus 1 plus x squared minus 4, and then combine like terms. This time you can add the negative 3 and the negative 4, and I'd get minus 5. 2 says f minus g, so this time I'm doing this minus this. So 3x minus 1 minus, and the biggest mistake here is not carrying that negative to both the terms after it. So make sure it changes both. 3x minus 1 minus x squared plus 4. And I get negative x squared plus 3x plus 3. Good so far. All right, then we have the composite function. So remember, we work inside out. So I would do g of negative 1 first. That means take negative 1 and plug it into my g of x. I get 1 minus 4, which is negative 3. That takes the place of this whole part, which means the second thing is to find f of negative 3, which would be 3 times negative 3 minus 1, negative 9 minus 1, which is negative 10. And then that is your answer. Not a two-part answer, but what you get at the very end. And then g of f of negative 2, g of f of negative 2. So negative 2 goes into the f. 3 times negative 2 minus 1, negative 6 minus 1, negative 7. And then g of negative 7 is negative 7 squared minus 4, 49 minus 4, which is 45. Questions on either of those? Okay, 1/6 was our inverse functions. So the first thing we talked about is if a function is 1-to-1, it has an inverse. If it's not 1-to-1, it doesn't have an inverse. And we talked about 3 different ways to discovering if it's 1-to-1. The first, well, not the first, it didn't go in this order, but one of the ways is from a graph. So what's your test to figure out if something is 1-to-1 or if it has an inverse? Using a graph. The horizontal line test, right? So if a horizontal line crosses your graph at more than one point, then it would not be 1-to-1, which means it does not have an inverse. So does number 1 have an inverse? No, it fails at every single point along the way, right? Does number 2 have an inverse? No. Does number 3 have an inverse? Yes. And if we needed to find it, we would plot our points. We would switch the x and y points to find the inverse, okay? Number 4 and 5 are now based on an equation. So how do I know if something is 1-to-1 if it's based on the equation? What are you looking for? The x can be raised to an even power or an absolute value. If either of those are occurring, then it's not 1-to-1, which means it doesn't have an inverse. So is 4 1-to-1? No. Or does it have an inverse? No. How about 5? Yes. Okay. So remember, this is the reverse of the test for a function. For a function, you're seeing, does the vertical line pass, and is the y being raised to an even power or the y an absolute value? That's to test if it's a function. This is to test if it's already a function, if it is 1-to-1 or have an inverse. All right, and then 6 is actually finding the inverse. So what's step 1? Good. Change the f of x to y. Step 2. Switch the y and the x. Step 3. Solve for y. So x minus 5 would equal 2y. Y would equal x minus 5 over 2. And then I can split it 1/2 x minus 5/2. What's the last step? Change this y to f negative 1 of x. Don't forget that step. It would stink to do all that work and not get to that last step, okay? As far as your test goes, unless you're graphing this, you can give me either of these, okay? You can give me x minus 5 over 2, or you can give me 1/2 x minus 5/2. Obviously, if you had to graph that function, you would split it so it's in slope-intercept form, and then you can graph it. Questions on either of the warm-ups? Okay, so on your, for your test review, okay, there is an assignment on Canvas that says R.1 to 1.6 test review. It is non-graded because the answers are there. I gave you mostly odd questions from your book so that you can check your answers, okay? The intent is that you're checking as you're going and not waiting for me to tell you what the answers are, okay? The review is for you to do. I am not collecting it. To go into a test without doing a review, if you've never done it before, don't start now, okay? If you've done it before, you know it usually doesn't go well, right? So my advice is make sure you spend time doing the review, okay? You guys have, I would say your goal is to do as much of the test review as you can before Monday, because then I can spend Monday in class answering questions that came up while you were taking your review, okay? If not, then you're leaving it all for Monday night, which is hard. Don't cram it in if you can avoid it, okay? So the first part of your test will be most of it without a calculator, and that's going to be Tuesday. So it's almost everything. The only thing that is not on that is the graphing calculator portion. On your test review, you'll see it's the last page. It says graphing calculator portion, okay? That will be given to you on Thursday. I think it's like 6 questions, but it's all based on one graph. So you're going to graph it in your graphing calculator, and then you're going to answer questions based on it. That's Thursday. Everything else is Tuesday. That's clear, right? Okay. I'm going to put it on your to-do list, but I didn't want to freak anybody out. So the actual assignment on Canvas has the topics that are covered in Chapter 1, and then I added in problems for R1 and R2 because those weren't in your book, okay? Those were also on your quiz. And then it starts with the chapter review that's in the book. I handpicked some problems, so I whited out a bunch of it, left what I wanted you to do. You don't have to do, it's a lot, you don't have to do every single problem. Just make sure you would know how to do every single problem, okay? And then all of the odd answers are in Calc Chat. The link to that is on the home page of Canvas, of my Canvas class. And the actual version is written right underneath that link. So you can check all of your answers as you're going, or do them all, check it. I don't care how you do it, okay? And then there's a couple evens. Those I will post. And the ones from R.1 and R.2, I will post the answers to those. Then there's a second extra review. So if you still need it after Monday, you want some extra review, do it. Answers are already there, okay? But make sure you at least look at all of it. Make sure you know how to do it all, okay? So what I'm going to try to do on this video is go through the concepts, not so many practice problems. The problems are on your assignment, okay? But I'll kind of talk about it, and then on Monday we can answer questions based on it. So we start with a lot of the stuff that was on your quiz, right? So not a lot of it, all the stuff that was on your quiz. R1. So R1 started with distance and the midpoint. These are both formulas you've got to know. So distance is the square root of x2 minus x1 squared plus y2 minus y1 squared. And this is how we find the distance between 2 points, and it's also referred to as the length of a segment connecting those 2 points. So we used this a couple ways. One was with the circles, and one was with the triangles. So if you're classifying a triangle, remember, that was question 1 from your quiz, right? That you could be classifying it to see if it's a right triangle, to see if it's an equilateral triangle, to see if it's an isosceles triangle. So for a right, you'd be finding the lengths of all 3 sides, and then doing a squared plus b squared equals c squared. Equilateral, you're looking for all 3 sides to match, and isosceles, you're looking for at least 2 sides to match. Well, 2 sides, because if it was 3, you would classify that better as equilateral. Okay, then midpoint was x1 plus x2 over 2, comma y1 plus y2 over 2. So sometimes it just said find the midpoint between these 2 points, but when else did we use the midpoint formula? If I gave you the endpoints of the diameter and you had to find the center, right? That was on your quiz too. So your quiz is a good resource. Everything except for the scatter plot you're going to see again. All right, R.2 was the graphs of the equations that we didn't really know what they were yet. These weren't parent function equations, okay? Some of them were y squared, some of them were x squared, some of them were both, some of it was cubed, all sorts of stuff like that. So the first thing it's going to ask you for, and the same thing as on your quiz, it's going to ask you for the intercepts. So if I want to find the x-intercepts, what do I do? Plug 0 in for y. And I want to see it in coordinate point format. So you will give it to me as a number, comma, 0. And there could be more than one, there could be none. The y-intercept, we do what? Plug 0 in for x. So here it would look like this. So this is usually when it involves factoring. Okay, make sure that you've reviewed your factoring. Again, if you are having a rough time with factoring, there's the video. I think it's on the 1.2 section of iTunes U. It goes through all the different kinds of factoring. So if you need that review, it's there. All right, then we did symmetry. So there was 3 ways that a graph can be symmetric. The first is to the x-axis, and if we're testing that, what do we do? Good. Change y to be negative y. For y-axis, we change x to be negative x. And for the origin, we change both the x and the y to negative x and negative y. And what are we looking to see happens after we do that? Good. So does the equation go back to the original? Or each term, every term. So if there's 6 terms, every single term has to change its sign. And remember, you can have x-axis and origin. You can have y-axis and origin. You can have all 3. You can have none. So this is that finding the equation of a circle given the endpoints of the diameter. So I'll work the rest of this out when you guys aren't here. But to find the center, we just talked about this. We would do what? We're going to find the midpoint. And then we have choices. I can either, to find the radius, find the distance between the midpoint to an endpoint. Or I can find the distance from endpoint to endpoint, but divide it by 2. Or I can plug in the center as my h and my k, and n endpoint, either endpoint, doesn't matter which one, as my x and y. And then I can solve for r that way. So you do whichever way works for you. So this is the third formula you need to know, right? Distance formula, midpoint formula, and then the circle. That's the third one. So with the example that's there, the endpoints of the diameter being 5, -3, and 7, 1, you'd start by finding the center. Use the midpoint, 5 plus 7 over 2, and -3 plus 1 over 2, 12 over 2, -2 over 2, and you get 6, -1. So that's your h and k. So you can start to build your equation. 6x minus h squared plus y minus a -1 becomes plus 1 squared, and then you've got to find your radius. So you can choose to either do any of those 3 options that are there, find the distance from the midpoint and an endpoint, find the distance from the endpoint, and each endpoint divide by 2, plug in the center and the endpoints as h, k, and x, y. So that's the option I'm going to take. I'm going to take one of those points. So I'm just going to use 5, 3 as my x and my y, and then use 6, -1 as my h and k, and plug it in. So 5 minus 6 squared plus 3 minus a -1 squared would equal the radius squared. -1 squared plus 4 squared equals the radius squared. and 1 plus 16 equals the radius squared. So the radius squared is 17. And that's what you finish off this equation with. So x minus 6 squared plus y plus 1 squared equals 17. Okay, 1, 1 was all about the lines. So graphing your lines, okay, 1, you can get it into slope-intercept format, y equals mx plus b. And then whatever the b is where you'll start on your y-axis, and then you'll use your slope to get your additional points. The only mistakes made on these on the quiz, and it's sad to say that there were mistakes made, is that you said your y-intercept was -4, and then you plotted the point at +4 when you went to go graph. So be really careful. It would sting to get points off for something silly like that, okay? Just be careful. And then we had exceptions where it was an x without a y. That's a vertical line with undefined slope. A y without an x. That's a horizontal line with slope equal to 0. In this section was the relationship between parallel lines. They have the same slope. The relationship between perpendicular lines, which is the opposite reciprocal. You could see something like this where it says find the equation given the points. So I would first find slope. I'm not going to work through it now, but I would first find slope. And then I would go back and plug it into slope or point slope, which is this. What equation are we on? Fourth equation you need to know. Technically, you need to know slope too. So I would first find the slope, and then I would take that and your x, either point, x1 and y1, plug it in, and then put it into into slope-intercept format. So again, unless it says otherwise, you're always giving equations in slope-intercept format. And then you saw a question like this on your quiz. Find the equation of a line that passes through this point that is A parallel and B perpendicular to a line with the given equation. Okay, so again, there's two different ones here. There's an A and a B. A in which the slope is parallel, and B in which the line is perpendicular. So what I need from this equation is what? Just its slope, right? That it's just saying find an equation with this point that is parallel to this line and then perpendicular to this line. So the only thing you need out of that is the slope. Do you remember the shortcut for slope if it's in standard form?
Yeah, it's A over B.
Negative A over B, good. So it would be -7/2. If you forget, then solve it for y and pull the m, okay? But that is a shortcut. So now, if I'm asking for the equation of a line that's parallel to that, what's true about the slope of that line? It's the same. So this would be -7/2. If I'm asking you to find the equation of a line in which it's perpendicular, it would be what? +2/7. So opposite reciprocal. So then I'm going to do y minus y1 using this point. So y minus 4 equals -7/2, that's my m, x minus a -5, which becomes +5, and then distribute, and then add the 4, which is the same thing as 8/2. So a lot of you got to the slope good, and then when it started dealing with fractions and that number, it got ugly, so be careful. So then if I'm dealing with the perpendicular side, still y minus and y1, which is 4, equals, now my slope is 2/7. X minus a -5 becomes +5. So then y minus 4 equals 2/7 x plus 10/7. And then I've got to add the 4, and 4 is the same thing as 28/7. So I get y equals 2/7 x plus 38/7. And you can leave it improper as long as it can't be reduced. All right, and then evaluating functions from an equation. So this is the start of functions. This is 1.2, I think. This is 1.2. So everything before that was on your quiz. And this is where the newer stuff started, okay? So if it says, if you're evaluating a function from an equation, you're identifying, you're saying something is or is not a function, We just talked about this. What are we looking for? When is an equation not a function?
If it's raised to equal.
If what is?
Oh, if x.
Other way around. So
Okay.
that therein lies where it starts to get confusing, right? Because now we've got both. Think about at the beginning, we had y equals equations, right? Can you picture that? We had y equals, and at the end they changed to f of x because they are already functions. So at the end, there is no y to see if it's raised to an even power or an absolute value. At the beginning, there is. So we're looking to see if y is raised to an even power or if y is an absolute value. So to see if it is a function, you're looking at the y. Okay, and then we got into evaluating piece. And how would you see it from a graph? Sorry, how do I see it from a graph? What's the test? Vertical line. And then our first introduction to evaluating to piecewise was evaluating them. So you were given what f of x is based on the different values, and then you were asked to evaluate a specific one. So in this case, f of 0. So for these, we want to figure out which of the three ranges this point lies in. So my ranges on this one are x is less than -2, x is in between -2 and -1, or x is greater than, or sorry, and +1, or x is greater than 1. So where does 0 fall? In the second one, so that means I take the 0 and I plug it in there and I get 1. For f of -2, same process. See where -2 lies. F is less than or equal to -2 in this one, which means I plug that same one in and I'd get -1. So make sure you pay attention to the less than and the equal to and all that stuff. In 1-3, we went back and graphed these. On your test, it's going to be grouped together. So you're going to get a piecewise function. It's going to evaluate that piecewise function and then graph the same one. But I separated it out in the review because it's in different sections. Questions? Okay. And then we talked about domain. So we've said it 8 million times. Hopefully this is now sunk in, right? Domain on a function is all real numbers except 3 cases. 1, if the variable is in the denominator, and for that one we would set the denominator not equal to 0. 2, if the variable is underneath the square root, and for that one we would set it greater than or equal to 0. 3, if the variable is under the square root and in the denominator, now what's underneath the root is greater than 0. And we're going to give domain in interval notation. Okay, this section also included your difference quotient. So your difference quotient is the what, I don't even know what number we're on. The 5th equation you got to know? This would be f of x plus h minus f of x all over h. So I'm not going to work it out right now. I'll come back to it. But the first thing I'm going to do is take f of x plus h, which means I'm going to plug x plus h into what they give me for f of x. And I get that big, long expression. And then from that, I'm going to subtract my original f of x, making sure I change the signs of everything after the minus. I'm going to simplify, and at that point, you should be able to cancel things out. If you didn't, you did something wrong. And then I'm going to put the whole thing over h, and usually you can simplify there too. So I will work this one out. Okay, and there are 2 to do on your review. If you feel comfortable after the first one, you don't have to do both of them, okay? Just make sure you know what you're doing. All right, so the first thing we're going to find the difference quotient is f of x plus h. So I'm going to take the x plus h, I'm going to plug it in to both x's that are here. So 4 times x plus h squared minus 2 times x plus h plus 1. And then I'm going to FOIL out the x plus h times x plus h. Distribute the -2. This is 4 times x squared plus 2xh plus h squared minus 2x minus 2h plus 1 distribute the 4x squared plus 8xh plus 4h squared minus 2x minus 2h plus 1. And that whole thing is f of x plus h. So then from that, I'm going to subtract f of x, which is 4x squared minus 2x plus 1. And when you subtract that, it changes all the signs after that minus. So from here, I've got a positive 4x squared and negative 4x squared, negative 2x, a positive 2x, and a positive 1 and a negative 1. So what's left is 8xh plus 4h squared minus 2h, and put it all over h. And then there's an h on each term, so I get 8x plus 4h minus 2. And that's the difference quotient. Okay, 1, 3 was all the graphs of functions. All of this based on your graphing calculator is Thursday's portion. But you're going to see it 2 places, okay? Mostly Thursday, where you'll graph a function and then you will answer each and every one of these questions based on that function. What's the domain and range? What's the increasing, decreasing behavior? What are the zeros? What's the max and the min? What's the interval in which it's greater than or equal to 0? And is it even or odd? Most of that is Thursday, but not all of it, because you will do domain and range on your transformations in 1.4. So make sure you can also identify domain and range from a graph. Like, don't skip this slide and say, oh, I'll study it Wednesday night. That would be bad. I would add to even and odd the test for even and odd. Oh, no, never mind. Yeah, I guess so. Because if you don't understand symmetry from a graph, then remember this would be by plugging in a negative x, and this would be by plugging in a negative x and a negative y. So your test for symmetry for y-axis would be a negative x. Test for symmetry from the x-axis would be negative x and negative y. So you can either use your graph or you can test it by plugging in your points. So this, like the overall one that is on your graphing calculator, again, is the last question. It's like the last page of your review. Okay, the end of 1.3 is graphing the piecewise function. So you had 2 options here. Only graph from the portion in which you want, like plug in points and see what it looks like, or graph your entire thing and erase what you don't need, okay? So if I do the second on the line, y equals 2x minus 1 means I'm going to start at negative 1, and I'm going to go up 2 into the right 1, and up 2 into the right 1, and I'm going to graph myself a line. But then it says it's only good for the values in which x is less than or equal to 1, which means I'm not starting until, which actually this is super sloppy line. The values wouldn't start until I got to here, and it would be an open dot, and it would point down, and I would erase everything else. And then it says f of x equals 3 for the values from negative 1 to 2. So what does f of x equal 3 look like? What kind of line is that? What is it when you have a y and no x? It's a horizontal line that would run right through 3. So this is going to get a solid dot on negative 1. It's going to go up to 2, and then it's going to have an open dot on 2. So it would look like that. Correct. Yep. And then the last one, we're going to do a rough estimate right now, but what I would have done is plotted points. It says x squared plus 3. So I would have done, okay, what's happening there? This is a 1, 1. I know that this is a graph that does this, but I need to know what happens where it's greater than or equal to 2. So if I plug in 2, I get 2 squared, which is 4 plus 3. That's 7, which means my dot is all the way up here. If I plug in 3, I get 3 squared, which is 9 plus 3, which is 12, which means my dot would be all the way up here. And it's for greater than or equal to 2, so it would look something like that. So you're going to need to know how to do all the different transformations on those parent functions. Reflection, so if the front is plus or minus, that's a reflection. The A here is going to make it narrow or wide. The plus or minus H on the inside is going to make it shift left or right. And then the plus and minus B at the end would be a vertical shift. So these are examples of your reciprocal functions. The parent function for your reciprocal function is the first and the third quadrant. Looks like that. There's a horizontal asymptote at 0 and 0 on both the y and the x. So in this equation, this is a shift left 2 and this is a shift down 3. So if you take your normal graph, shift it left 2 and down 3, that means that that is the point in which your asymptotes are running through. And so your curves would go top right, corner, bottom left. So domain here, normally it goes negative infinity to 0, but because we shifted to the left, it's now negative infinity to negative 2, and then negative 2 to positive infinity. And the range normally goes negative infinity to 0 because the x-axis is usually asymptote, but because this got shifted down 3 places, it's from negative infinity to negative 3, union negative 3 to positive infinity. In this example, this is your flip, right? This is over the x or upside down, and this is up 2. So my normal graph with 0, 0 is getting shifted up 2 places. That's where my horizontal and my vertical asymptotes are. And instead of it being here and here, it's upside down, so it's here and here. So domain left to right, negative infinity to 0, and 0 to positive infinity. Range bottom to top, negative infinity to 2, and 2 to positive infinity. In this section, you'll also be asked to find the equation from a graph. So in this graph, we know this is a square root of x function. We know this is shifted right 2 places and up 1. So this function would be the square root of x minus 2, because that's right 2, and plus 1 at the end, because that's up 1. 1, 5 is your combined functions. So all the things that we did in 1, 5, we took 2 functions and added them together, then subtracted them, multiplied them, divided them, and then this is your composite function f of g of x. So you can do this with just the expression or the equation. You could do it with values, and you can also do it with the graphs. And then 1, 6 was the start of the inverse functions. So it is a function, had an inverse. From points, you're looking to make sure that no y repeats with a different x. So an example of what does work as a function is if the y's are all different. That is that is 1 to 1, so it has an inverse. If this here was a, let's say 5, where the y repeated, but they doesn't match the x, then this is not 1 to 1 and does not have an inverse. From an equation, a function would have an inverse as long as the x is not raised to an even power, or the x isn't in absolute value. So if those two do exist, then it's not 1 to 1 and it does not have an inverse. And from a graph, you would use the horizontal line test. Then to find the inverse, so if you're given something like f of x equals x minus 3, then the first thing we do is change f of x to be y. Then we switch the x and the y, solve for the new y, and change the y back to f negative 1 of x, showing that this is now the inverse. And then the way you would check to see if one of these is the inverse of the other, then you verify by plugging one of the functions into the other and simplifying. You should get x, both the f negative 1 of x and f of f negative 1 of x. So with this example, this is pretty simple, but just to show quickly, I would switch, and then I would solve for y. So f negative 1 of x would be x plus 3. So if I found f of f negative 1 of x, that means take what I found and plug it into my original one. So this goes in here, x plus 3 minus 3. These cancel. I'm left with just just x. And then f negative 1 of f of x. Now I'm taking this and plugging it in here, and I get x minus 3 plus 3. These cancel, and I'm left with just x. So when you've got the extra time, you can definitely simplify those to see that they're x.